Hello everyone. Welcome to this detailed session on sampling and statistics. I'm Dr.T.Linga Murugeshwari, Assistant Professor of Economics at Sharda College for Women 7. Today, we are going to take a deep dive into one of the most fundamental concepts in statistics, sampling. This is a topic you will not only encounter in your academic coursework, but also in practical economic research, policy making, and survey design. In this lecture, we will explore what sampling is, why it's used, the types and techniques of sampling, and their merits and limitations. By the end, you will have a solid grasp of how sampling works and how to choose the right method based on your research objectives. Let's begin. In this session, we aim to achieve four key objectives. First, we'll understand what sampling is and why it is important. Next, we'll look at the difference between a population and a sample. Then we'll explore various sampling methods used in statistics. Finally, we will evaluate the merits and limitations of each sampling method. By the end of this session, you should be able to identify suitable sampling methods for different research problems. Meaning of sampling. Sampling refers to the process of selecting a subset of individuals from a larger population in order to analyze and draw conclusions about a whole. It's a fundamental tool because in most real-world cases, studying an entire population is either too expensive, too time-consuming, or outright impossible. Imagine trying to survey every household in India about their monthly income. That's a logical nightmare. But if we select a carefully chosen sample, we can still gather data that is statistically meaningful, representative, and actionable. Why do we use sampling? There are several key reasons. Economic resources. It saves time, money, and effort. Feasibility. In many cases, accessing the entire population is simply not possible. Speed. Data for samples can be collected, processed, and analyzed much more quickly. And focusing on a smaller group allows for more in-depth and higher quality study. Population versus sample. Now let's clarify two crucial terms, population and sample. A sample refers to the entire population that we are interested in studying. This could be all women in Tamil Nadu, all college students in Tamil Nadu, or all households in a rural district. A sample is a subset drawn from the population. If our population is all college students in Tamil Nadu, a sample might be 300 students selected from 15 colleges. The key is representativeness. A sample must reflect the characteristics of its population as closely as possible. Next is types of sampling. Sampling methods are generally categorized into two main groups, probability sampling, non-probability sampling. Let's go through each in detail. In probability sampling, every individual in the population has a known non-zero chance of being selected. This is the gold standard for scientific research because it supports valid generalizations about the population. This includes methods like simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Non-random sampling, where some members may not have a chance of being selected. This includes judgment sampling, quota sampling, convenience sampling. First, we'll see about simple random sampling. In this method, each individual has an equal probability of being selected. Think of drawing lots or using a random number generator. It's straightforward and unbiased, but it can be inefficient for very large or dispersed populations. Next is systematic sampling. Here we select every kth unit from a list after choosing a random starting point. For example, starting at the 5th name on a list and then selecting every 10th name, it's efficient and easy to implement. But it can introduce bias if there is hidden pattern in the data. Next is stratified sampling. This is the method divides the population into distinct groups or strata based on characteristics such as age, gender, or education level. Then a random sample is taken from each group. It's especially useful when different subgroups need to be represented proportionally in this sample. Next is cluster sampling. In this method, the population is divided into clusters, usually based on geography. Then a few clusters are randomly selected and all units within those clusters are studied. It's cost effective for widespread population, but increases sampling error if the clusters are not homogeneous. Next is non-probability sampling method. In contrast, non-probability sampling does not give all individuals a known chance of being selected. While less scientifically rigorous, it is often used in exploratory research or when the probability sampling isn't feasible. Let's cover the main type. Convenience sampling. Convenience sampling involves selecting individuals who are easiest to reach, like surveying people at a shopping mall. It's fast and low cost, but the results can be heavily biased. Next is judgmental sampling, also known as purposive sampling. Here, the researcher uses their judgment to select respondents they believe are representative. This method is commonly used in qualitative research or expert biased research. Next is quota sampling. In this method, the population is segmented and a fixed number of subjects are chosen from each segment. However, unlike stratified sampling, the selection within segment is non-random. It ensures the representation but suffers from potential bias. Next is merits of sampling. Let's summarize the benefits: time efficiency, cost effectiveness, greater control over data collection, detailed analysis of smaller groups, flexibility in study design. Next is limitations of sampling. But there are also some drawbacks: risks of bias if the sample is not representative, and errors in selection can distort conclusions, not suitable for certain critical or legally sensitive studies. Then sampling variability, results can vary from sample to sample. Sample versus census method. Let's now compare sampling with the census method. A census involves collecting from every member of the population. It provides the highest level of accuracy, but it is extremely resource intensive. Sampling, by contrast, is much faster and more economical. If the sample is well designed, results can be almost as accurate as a full census and much more practical. Think of the government census. which is conducted every 10 years due to its scale and cost. On the other hand, sampling based surveys are used frequently and flexibly to inform policy economics. Practical applications in economics. Sampling is a cornerstone of economic research. The National Sample Survey Office uses probability sampling to collect data on employment, expenditure, and consumption. Budget surveys sample households to analyze income spending pattern. Agricultural surveys rely on village sampling to assess productivity and practices. Companies conduct market research using sampling to understand consumer preferences. Understanding these applications shows how central sampling is to economics, policy making, and social sciences. To conclude, sampling allows us to analyze large populations using small, manageable subsets. The key is in choosing the right method, ensuring representativeness, and understanding the trade-offs involved. As economic students, mastering sampling techniques will not only help you in research and exams, but also in analyzing policy, reading reports, and evaluating data in the real world. Thank you for joining me in this session on sampling in statistics. I hope this helps you to understand the topic more deeply and confidently. Thank you.